Welcome to my YouTube channel. I am your entrepreneurship tutor, Professor Henry Bwisa of Jomo Kenyatta University of Agriculture and Technology. Today, I want to talk about research, and I want to say that observational research is actually scientific. Yes, an act of handshake between two top Kenyan politicians who were previously antagonists developed into a building bridges initiative, the BIB Philosophy. And this sparked off a national campaign to sell the BIB philosophy to the populace. Now, when politician undertook to collect views about BBI in his constituency, the politician said he made observations and interviews and concluded that the BBI was not popular among his constituents, partly because it has not been well promoted or sold. And the politician converted his report into a letter to the president, who was the other hand in the handshake. Yes, he used observations, he used interviews, and I guess he also used focus group discussions, because he must have sat with colleagues and all that. Now, the letter the president leaked to the public, and all hell broke loose, with the politician being blasted by many fellow politicians and even some newscasters for being, one, unrespectful to the president, and two, unscientific in his approach to research. His observation method was labeled unscientific. And this came at a time when I was coaching and mentoring my students of entrepreneurship on research by observation. So definitely, the students had to ask me to prove that observation is scientific, given the uproar against this politician. So I'm here forced to re-emphasize that observation is a scientific method of research. Let me borrow wholly from this source. In this source, the scientific method is simplified and demystified. It says, at the core of biology lies a problem-solving approach called the scientific method. I think this is applicable to all sciences, including social sciences. Of course, this is my addition. And the source goes on to say, this problem-solving approach has 5 basic steps. And the listed 5 are: make an observation, ask a question, form a hypothesis or testable explanation, make a prediction based on the hypothesis, then test the prediction, and then finally iterate. Use the results to make new hypotheses or predictions. Now, we have been given an example at that source of 2 slices of bread being put into a toaster and pressed the button. However, you may do that and find that your bread doesn't toast. Then, of course, you may become curious and start with an observation. So, you found something, your toaster didn't toast. Then you observe, the toaster won't toast as an observation. You'll then ask yourself the question, why didn't my bread get toasted? So that's the second stage. You have observed something, then you ask why this something. Why won't my toaster toast? Next, you may pose a hypothesis. Now, a hypothesis is a potential answer to the question, one that can somehow be tested. For example, our hypothesis in this case could be that the toast didn't toast because the electrical outlet is broken. So that is stage 3. No, observation, questioning, and then setting hypothesis. Maybe the outlet is broken. This hypothesis is not necessarily the right explanation. Instead, it's a possible explanation that we can test to see if it's likely correct or if we need to make a new hypothesis. So, you may then make a prediction. A prediction is an outcome that would expect to see if the hypothesis is correct. In this case, we might predict that if the electrical outlet is broken, then plugging the toaster into a different outlet should fix the problem. So that is prediction. If I plug the toaster into a different outlet, then it will toast the bread. You then test the prediction. To test the hypothesis, we need to make an observation or perform an experiment associated with the prediction. For instance, in this case, we would plug the toaster into a different outlet and see if it toasts. So there it is. Number 5, test your prediction. Plug the toaster into a different outlet and try again. Now, if the toaster does toast, then the hypothesis is supported, slightly correct. If the toaster doesn't toast, then the hypothesis is not supported, likely wrong. The results of a test may either support or contradict or oppose a hypothesis. Results that support a hypothesis can't conclusively prove that it's correct, but they do mean it's likely to be correct. On the other hand, if results contradict a hypothesis, that hypothesis is probably not correct unless there was a flaw in the test. A possibility we should always consider. A contradictory result means that we can discard the hypothesis and look for a new one. So the last step of the scientific method is to reflect on our results and use them to guide our next steps. Look, the result is my bread toasts after changing the sauce, the plugins. The hypothesis is supported because the bread toasts. But what is actually wrong with that outlet? That is now iteration time. What is actually wrong with the outlet that didn't work? But if my bread did not toast, the hypothesis is not supported. And they say, maybe there is a broken wire in the toaster. So we go back and look at now the wires. So we started with the observation and we came into iteration time. So observation is a scientific way of doing research, and particularly qualitative research. Now, here is my own case study. I observed mama mbogas, the ladies who sell vegetables at Chwele Market in Kenya's Bungoma County, and I noticed that some sell bundles of whole leaves of sukuma, the kales, while others cut off the stems and shred the plates and veins before they sell. Look at the leaf, the diagram of the leaf of the sukuma. There's the stem, there are the veins and the plates. Now look at these women. Some of them are shredding, cutting the sukuma to sell them when they are in cut form. Of course, I interviewed them. I talked with them. Look at how they are doing it. Very smart. That knife is very sharp, but they can't cut each other. I observed. I saw all that. The ones that are selling whole bundles are not visible in this video. The ones that are cutting to sell in cut form are visible. These are the ones you are seeing. They do it like mechanically. Look at the speed. Look at the accuracy. Demand for the shreds is shredded sukumas is quite high. So I noticed that the customers who buy bundles of whole leaves were generally older and married, and those who buy shredded sukumas or kales were generally younger and single. Now, brief interviews revealed that some of those buying whole leaves use the stems at home to feed their chicken. Others make compost manure out of the stems. Many of those who bought shredded leaves said they have no time to shred at home, and the stems make unnecessary waste at home, yet they do not have the time to deal with too much waste. Yes, observing further, the sellers who shred revealed that they actually dump the stems around the market, and that this increases the cost of cleaning the market and the market environment, let alone the associated health hazard. You can see this is actually a dump site by the market, and that is the market. This is actually Kawangware in Nairobi. Now, further interviews. I interviewed nutritionists, and consulting literature revealed the human benefits associated with the stems of the sukuma. Look, they are the leaves and the stems. The stems can be cut before the leaves are shredded. And those stems that are cut, as I said, those who don't shred them, they go to waste. But then nutritionists told me, look, these stems contain lignans whose attributed health benefits include a lowered risk of heart disease, menopausal symptoms, osteoporosis, and breast cancer. The same stems contain carotenoids, which are said to act as a type of antioxidant for humans. And lastly, the same stems contain glucosinolates, which are said to have regulatory functions in inflammation, stress response, phase 1 metabolism, and antioxidant activities, as well as direct and microbial properties. So you see, I discovered that. Now, knowing the benefits, I undertook an experiment. I collected the stems from the women who shred sukuma, chopped them into tiny pieces, and sun-dried them using a solar dryer, which you can see there, that I replicated from the internet onto my rural home plot. When they dried, I ground them into flour using kitchen blender. The flour made very good soup thickener. So you see, that is my sun dryer. I can use it even to dry charcoal briquettes. I can use it to dry seeds for putting in the nursery. I use it for drying vegetables, and therefore I used it to dry the chopped sukuma stems, and when they were dry, using a blender, I ground them into powder. And that powder, I used it to thicken soup, just like other soup thickeners. But you see, the properties of the stems that we have already seen, they have now used. It's not just thickener, it is thickener, but it has got those benefits. So, from observation, I came to experiment and experimented on this, set up this sun dryer, which can use both the sun, but at night you can fit in your charcoal and your firewood, and it will still dry whether there is sun or not. It will dry even when there is rain. So this is an improved solar dryer which I have now installed in my rural home. It worked for me, and therefore I replicated it back to Nairobi, next to my university, because of the excitement that I got the results, which started with observation, and now I use it to incubate students. This is the dryer now, the second dryer on my farm. This, a student has now prepared this plot. The student is going to grow here vegetables. It is dry season now. Grow the vegetables. She will actually, the student will now either dehydrate the vegetables themselves or cut the stems, dry them, and turn them into thick, soup thickener. So this is an incubation plot, an agro incubation plot on my plot in Juja town next to Jomo Kenyatta University of Agriculture and Technology, and the students come here to incubate. There are other activities that go on, charcoal briquette making, cricket farming, and all that. Now, in conclusion, I want to underline the fact that observational research or field research is a type of non-experimental research in which a researcher systematically observes and records ongoing behavior. The general goal of observational research is to describe a variable or a set of variables. More generally, the goal is to obtain a snapshot of specific characteristics of an individual, group, or setting. So, it's unfortunate that observational research was labeled unscientific. Maybe the people who thought it was scientific are biased towards quantitative analysis. But qualitative research, qualitative analysis uses observation, uses interviews, uses focus group discussions, uses opinion leaders, and that is scientific. Thank you, and be observant to keep safe. If you enjoyed it, please like it, share it, and subscribe. Thank you for listening, and please use observations comfortably to do your research. It is scientific.